represented. Okay. Okay. Now within a circle or congruent circles, if we have two circles or in the same circle, if we have congruent arcs here, if ST is equal to UV, then the central angles are equal, x degrees and x degrees, as you can see. Or if the central angles are equal, then the corresponding here arcs are also congruent, or the measures are equal. Okay, so the theorems that we will apply in order to solve the problems later here, if we have two congruent central angles, so the two chords in front of these two central angles are also congruent. If angle EAD is congruent to angle BAC, then the chords are congruent. Chords DE is congruent to the chord BC. DE is congruent to BC. Also now, if it is given that the chords are congruent, if ED is congruent to CB, then the arcs here are congruent. Then arc ED is congruent to arc CB. The third one, if we have congruent arcs, if arc ED is congruent to arc BC, then the central angles are also congruent. Okay, let's apply these three theorems. The first example here, 3E. The first example now, applying congruent angles, arcs, and chords. If the chord TV is congruent to the chord SW, find measure of arc WS. We said if the two chords inside the circles are congruent, then the arcs are also congruent. This arc is congruent to this arc. Okay, apply the theorem. Chords have congruent chords, then congruent arcs. Okay, substitute now. 9n, so 9n minus 11 equal to 7n plus 11. Now solve for n here. Move the 11, negative 11 to the other side to get 11, and move 7n there in the left side in order to get 2n. Now divide by 2 both sides to get n equal to 11. Now we want to find measure of arc WS, which is 7n plus 11. Substitute n equal 11. We will get now measure of this arc after we simplify 88 degrees. The second example is also applying congruent angles, arcs, and chords. If circle C is congruent to circle G, we have here two circles, two congruent circles. Two congruent circles means that the radius for the first circle is equal to the radius for the second circle. And measure of the central angle G in the first circle is equal to the central angle C in the second circle. Okay, find NM. Find the length of NM. Find the length of the chord NM. Now, since the two central angles are congruent, then the two arcs are congruent and the two chords also are congruent. So we will write the equation, which is 14t minus 26 equal to 5t plus 1. Solve for t. Here move 5t to the left side and move negative 26 to the right side to get 9t equal to 27. Divide by 9 both sides, then t is equal to 3. T is equal to 3. We want to find here NM. NM is equal to 5t plus 1. So substitute 5 times 3 plus 1 equal to 16 units for the chord NM. Okay, now here the second theorem, or the second part of the theorems here in this lesson. The theorem says in any circle, if the radius is perpendicular to any chord on the circle, look, CD is a radius. Now EF is a chord. EF is a chord. If the radius is perpendicular to the chord, which is EF, then this radius definitely is bisecting the chord EF. And also the converse of the theorem, which is if the circle, now here, if the radius bisect the chord, then it is perpendicular to it. In a circle, this in here also, this is a diameter. In a circle, the perpendicular bisector of a chord is a radius. Of course, it will be a radius. If it is perpendicular and a bisector, then this is a radius for the circle. Apply this theorem. To apply this theorem here, find NP. NP. This is a chord, and this is RM, is a radius. Now the radius is perpendicular to NP, 90 degrees, and the lengths here, it is clear on the figure. Find RN. We want to find the radius. This is the radius. Now this is an here Rn is equal to 17 radius of circle R. Step number 2, use Pythagorean theorem. Look here, 8 plus 9 is equal to 17. All the radius here is equal to the radius there, so it will be also 17. Now we can apply Pythagorean theorem in this triangle to find n here, this half of the chord. So we will apply Pythagorean theorem. Here Sn squared, half of the chord, Sn squared is plus 8 squared is equal to 17 squared. Now move the 8 squared to the other side. So Sn squared equal to 225. Put the square root for both sides to get Sn is equal to 15. Sn is equal to 15. According to the theorem that the radius is a bisector of the chord if and only if it is perpendicular, so NP will be equal to 2 times 15, which is 30 units. Also here we have, look here, we have the radius PS and we have the chord QR. PS, the radius, is perpendicular to QR, so it will be also a bisector. Again, what is the radius here? The radius is 10 plus 10, which will be equal also to the radius PQ. So in this triangle, which is PTQ, it is a right triangle. We know this, which is 10, and this is 20. This is how we think of the question, 20. So we can apply Pythagorean theorem to get QT, which is half of QR. Okay, let's apply the steps here. Draw radius PQ. Then PQ is equal to 20 since it is the radii of the circle. Step 2, use the Pythagorean theorem as we said in order to get it. Or here we can use, if you remember, the special right triangle. I think you know that the answer will be 10 radical 3. Let's see. Now apply Pythagorean to get here TQ square is equal to 300. Take the square root for both sides, so to get 17.3, or it is 10 radical 3. Now find QR. QR multiplied by 2 to get 34.6 approximately, of course, or 20 radical 3 if you are writing it in radical form. Thank you for watching, listening, concentrating. Goodbye.